All right, welcome to our video on oxyacid salts. Before we take a look at what oxyacid salts are, we have to be clear on what oxyacids are. And here are a few examples. So I've got H3PO4, that's an oxyacid, and so is H2SO4 here. Now, oxyacids, as you can see, are compounds that contain hydrogen and a polyatomic ion with oxygen in it. So here, I've got hydrogen and sulfate, and together this makes sulfuric acid. Here I've got hydrogen and phosphate, together it makes phosphoric acid. So how do you go from an oxyacid to an oxyacid salt? So oxyacid salts are formed when some of the hydrogen, so some of that hydrogen in that oxyacid is replaced by a metal. So let's take a look at an example like this. So H2SO4. So this, as we mentioned, is sulfuric acid. What happens if I take away one of these hydrogens and replace it with, say, sodium? So then I get something like NaHSO4, right? So this is an example of an oxyacid salt. This is an example of an oxyacid. So in order for us to indicate that there is a hydrogen in this oxyacid salt, we have to make note of that in our name. So we would use things like prefixes like hydrogen, or we'd use the prefix bi, or we'd say dihydrogen when there are two hydrogens. Let's take a look at how we would get each of these different types of naming situations. So let's start off by looking at the oxyacid, right? It's very important to understand how these oxyacid salts are formed. And in order to do that, we have to start off with our oxyacids. So I've got three different ones here. I've got sulfuric acid at the top, carbonic acid, and then phosphoric acid. Notice the key difference here. Sulfuric acid and carbonic acid each have two hydrogens there, but phosphoric acid has three hydrogens, and we'll see how this changes all of the ions that could be formed. So let's try and do exactly what we said. We're going to replace one of these hydrogens. We're going to remove one hydrogen from each of these oxyacids. So if I remove one hydrogen from sulfuric acid, I end up with HSO4, and this entire compound has a charge, this entire ion has a charge of -1. And if I were to name a situation that has HSO4, I would name it as hydrogen sulfate. Or, so this is where I can use either or of these names, I could also name it as the bisulfate ion. Now let's take a look at carbonic acid. Very similarly, if I take away one hydrogen, I have this ion here, HCO3, and this entire ion has a charge of -1. And when I name it, very similarly, I would name it as hydrogen carbonate, of course, because we've got the carbonate ion here, or bicarbonate. Now, phosphoric acid is different, again, because it starts off with three hydrogens. If I were to take away one hydrogen, I still have two left over. And this is very easily indicated in the name because we just say dihydrogen, di meaning two. So dihydrogen phosphate is how I would name a compound that contains H2PO4. So H2PO4, this entire ion, has a -1 charge. Notice that if I'm taking away one hydrogen, all of these ions have a -1 charge. Now, what happens if I were to take away two hydrogens from all of these oxyacids? Now, starting with H2SO4. H2SO4 only has two hydrogens. So if I were to give away or take away these H's, you would end up with your sulfate ion. Now, this is not an example of an ion that forms an oxyacid salt, right? This is just our polyatomic ion, SO4 with a charge of 2-. Same with carbonic acid, because it only has two hydrogens, and if it gives away, or if those are taken away, it would just go back to its polyatomic ion. This does not form an oxyacid salt because it doesn't have a hydrogen in it. Now let's take a look at phosphate. We had 3 hydrogens to begin with. If we give away 2, we take away 2, you end up with 1 hydrogen, PO4, and a charge of 2 minus. So this entire ion has a charge of -2. And if I'm naming these, I would name it as hydrogen phosphate or biphosphate. Notice the similarities between HPO4 -2 and these ions here. Whenever there is 1 hydrogen with that polyatomic ion, you can use hydrogen sulfate, hydrogen carbonate, hydrogen phosphate, or bisulfate, bicarbonate, biphosphate, right? That's when you have 1 hydrogen that's sort of left over. If all of the other hydrogens have been removed and you've got 1 hydrogen that's left over to be able to form that oxyacid salt, right? So that's sort of how the ion formation works. Now let's take a look at what oxyacid salts look like. So these are when the metals have been inserted in. What we've looked at so far are the ions. Right, before we go on, H3PO4, if I were to remove all 3 hydrogens, I would have the phosphate ion that's left over. All right, let's try and name each of these. If I've got NaHCO3, so I've got CO3 and 1 H. So if I take a look at my chart here, 1HCO3, that can be named as hydrogen carbonate or bicarbonate. And I've got sodium here, so I'm going to have to make sure that I indicate that as well. So sodium, hydrogen carbonate, or, and either one of these works, sodium bicarbonate. And that is baking soda, carbonate. All right, let's take a look at our next example, MgHSO4. Again, 1H and sulfate. Same thing as always, if I have 1H in that polyatomic ion, I can name it as hydrogen polyatomic ion or bi something. So let's see. So magnesium is my metal here, so magnesium bisulfate. And you can name this as magnesium hydrogen sulfate. That is still correct. I'm just using magnesium bisulfate. All right, let's take a look here. I've got phosphate, but I've got 2 hydrogens, right? So my metal here starts off, let's start with potassium. And because there's 2 hydrogens, I'm going to call it dihydrogen phosphate. Okay, and let's take a look at our next one. So instead of it being SO4, I've got SO3 here, but that doesn't change anything except for the ending. So instead of it being sulfate, I've got sulfite here. And I've got 1 hydrogen, so again, I can use hydrogen sulfite or bisulfite. In this case, why don't I use hydrogen sulfite? And I've got my metal, which is copper. Now here's where everything that we've learned about comes together. Copper is a transition metal, which means that I'm going to have to specify the charge of copper. And I don't readily know it without having to identify, or I won't be able to identify it without looking at the charge of HSO3. So I know, let's start off here. Let's think about this. SO3 has a charge of -2. If there's 1 hydrogen here, the charge of HSO3 is going to be -1, right? And because the charge of HSO3 is -1, the charge of copper has to be 1 as well. So I'm going to write down in Roman numerals, copper 1 hydrogen sulfite. I can also write copper 1 bisulfite. Those are both acceptable names. All right, let's take a look at our last example here. Again, I've got a slight variation here, so not PO4, but PO5. When there's an extra oxygen, I have to add the prefix. So it's going to be per phosphate. I only have one hydrogen, so I'm going to name it as hydrogen. And my metal is lithium. So my entire name is lithium hydrogen perphosphate. And that's it for oxyacid salts.